Hi everyone. So today we're gonna start to work on chapter 4. And keep in mind that when we finish chapter 4, we're gonna have exam number 1. Today I will cover 4.1 and 4.2. 4.3 I think I will cover in the next on the next Tuesday, and then we're gonna have review day on Thursday next week. Then you're gonna have exam 1 on the next following week. Okay, so let's move to the chapter 4. Chapter 4, we're gonna talk about cost, revenue, and profit function. Um, Today we're gonna talk about application of quadratic function, and then piecewise define functions. Okay, so let's move down. Okay, so section 4.1, application of quadratic function. In here, we're gonna talk about cost function. You have learned that the cost function is Cx equal to f plus v. This is v times x. F is, remember that F is fixed cost, and V is variable cost. Okay. And then, no, actually, we have under here, right? And then we also want to learn about the price demand function, which is actually the price demand function, P of x equals to M minus NX. Okay. And P of x is a price per unit. The price per unit decrease as the number of units produced increase, usually in the real life, in order to have the price and the less price, you have to buy more. So that's the reason why you say price decrease when the number of units increase. Okay, then revenue function. Revenue function is in here. It's a R respect to P, but I'm gonna write as R respect to X. Okay. And and the revenue function is P times P of X times X. Okay, so in another way, they use revenues function in term of price. So that's the reason why they have RP equal to P times with X of P. Okay, this is X of P. All right. So then you're gonna have X times M minus NX. Actually, this is not a correct one. I'm pretty sure. All right. So they mean that they are using revenue in terms of X. So in here, you should know that P of X here is the price demand function, which is up here. And then that's going to be equal to M minus NX. And then time with the X. So then you will have xm minus nx squared. Okay. Now, we will have profit function. Profit function P of x equal to Rx minus Cx. What does that mean? Profits always equal to the revenue subtract for the cost. So you have to remember this will stay forever with you if you are learning about business, right? Okay, so now let's move down. So let's do an example. Okay. Example 1. Publishing a book. If the price function is p of x equal to 200 minus x, find the revenue function. Price and revenue are dollars. X is the number of items sold. Okay, so you remember that revenues equal to p of x times with the x, right? Then you're gonna just substitute from the price demand function here into this p of x, and then you're gonna have 200 minus x times x, and then do distribution. You will have a negative x squared plus 200 x. Okay, because I did this one first. Okay, so I mean, yeah, I want to have the x squared at the first term. So okay, now I have this is a function of the revenue function, and this also is a parabola because what? Because this is a quadratic form, quadratic function, right? Okay, so so now in order to draw this quadratic function, you need to list what's a. A in here equal to -1, right? See that. B in here, what is the B? 200. And C in here equals 0. So, but I don't care about that. So I want to have the vertex, which is H comma K. And H, remember from the last section, we have H equal to negative B over 2A. So I have put negative B is 200 over 2 times -1. So then easily you're going to have this as equal to 100. Okay, so I have H equals to 100. What about K? K gonna be the revenue with the input equal to 100, right? So you wanna use this function, right? So I have K will be equal to the negative, right? X squared. So I put something square. So that's is 100, right? Input now is 100 plus 200 times with something. What is that thing? 100. Okay. So now use a calculator. You should have K gonna be equal to 100. No, it's gonna be 10,000. 10,000. Okay. So what does that mean? You are having K gonna be K right now be equal to 10,000, and H is 100. So then the vertex HK now become 100 and 1,000, 10,000. Sorry. Okay. So demo this. Now I will have the vertex first. So I have 100 here. I move up to 10,000. It is 10,000. This is a point of vertex. And that's 10,000. Okay. So if you would love to see the other two x-intercept, right? You need to let the revenues equal to 0. So let's a of x equal to 0, and you're going to use a factor form to make it easy. You're going to have let me move this a little bit to here. So you're going to have 200 minus 4x multiplied by x equal to 0. Then use zero factor probability. You will have 200 minus x equals 0 or x equals 0, right? And then you will have x equal to 200 or x equal to 0. And the two x-intercept of the function. So you have I'm gonna say x-intercept will be 200, 0, and 0, 0. So 0, 0, 1 point, 200 and 0, 1 point. Then you can just draw the graph smoothly. I hope this look good. It's, I mean, it just approximately it look like this. I don't wanna like try to make it very accurately, but you should at least have 3 points to grab this parabola. And if you want to make it more accurate, you can make a t-table and then make some more order pairs to make it more accurate. Okay. Now let's move down. Okay, this is another example about selling apps. The price function for selling our app is P of x equal to 10 minus x over 1,000. If we sell between 2,000 and 8,000 app download, find the revenue function. Price revenue in dollars. X is number of download sold. Okay, so firstly, in order to find the revenues, you should know that you need to follow the formula P of x times x, right? Then P of x is based on this formula. You have 10 minus x over 1,000 times x. Okay, then you're gonna try to distribution it. I'm gonna use the x with x first. So I have negative of x squared over 1,000 and a plus with a 10 of x. Okay, I would like to write in the form at m at the form of the slope intercept. So I'm gonna write as say negative 0.001 x squared plus 10 of x. And that's gonna be the form, quadratic form, right? Quadratic. And then easily you're gonna have a equal to 0.01 B equal to 10 and C equals 0 in this case. So if you want to find the vertex, you're going to have H equal to negative B over 2A, right? So negative 10 over 2 times negative 0.01. And then that's going to be equal to what? Use a calculator. Yeah, you're going to have 2.01. You're going to have 500. So this is going to be equal to 500. Okay. Then for K, you're going to substitute into the revenue function with a, is that 500 or 500? Let me, oh, actually 0.001, yes. So that's 5,000. I can't write 5,000 here, but okay. So one more zero here. So you're gonna have put 5,000 into the function of the revenue for the x, right? So you have negative 0.001 times 5,000 square plus with a 10 of 5,000. And use a calculator, you're gonna have K equal to 5,000 square and multiplied by 0.0. Plus with so you're gonna have 25,000. Okay, so then the vertex. Let me circle this. Vertex should be in the form as order of 5,000 and 25,000. So let me circle this. All right, and then vertex was 5,000. So here's 4,000. 5,000 is in the middle. Here 2,000, 4,000, 6,000. Okay, so when we right here, 5,000. You can move to 25,000 up. That's gonna be the vertex. Okay. And in order to find the act in itself, you still have to do let x equal to 0. So you're gonna use this form in the factor form. So you have 10 minus x 1,000 and x equals 0. Then you have 10 minus x over 1,000 equals 0 and x equals 0. In two cases, and first case will give you x equal to, so you're gonna subtract 10 both inside and divide it by no, multiplied by nearly 1,000 volt inside, you're going to have 10,000. So it's 10,000 and it is 0. So you have 10,000 gonna be the last one. And this one. Okay, so let's try to, too much. Okay, so, uh-oh. All right. So this is a graph of this parabola, but try to read carefully before you leave. There is one information that we haven't used, is if we sell between 2,000 and 8,000 app downloads, that means what? That means you just care about from here to from 2,000 to 8,000 only, right? So yeah. So then you don't need to have the graph in between from 0 to 2,000. So let me just have like a dot line to there, and then this one will go up to, and all right. So our graph should be I'm gonna have the blue line and the blue one for you to recognize easily. Okay, so that is our graph for in between 2,000 and 8,000 app downloads. Okay, so we move down. Okay, this is a profit. Let's talk about the profit now. Okay, profit involves both of the sale of item and cost to make them. Now assume that the fixed cost to make the item is 6,500 and that the per item cost is 20. Then the cost to make X item is okay. So in order to find the cost, you need to know that that's going to be F, the fixed cost, plus with the variable cost times X. So in here, you know that the fixed one was 6,500 and the variable is V. So then you're going to have 6,500 plus 20x. Okay, and now they want to find the profit, and the profit is revenue subtract for the cost, right? The difference between the revenue and the cost. The thing in here, I don't see the revenue function in this column, and the revenue, and in this graph, it look like exactly to the revenue function in the previous, in the first example. So let's move back to here, and I'm gonna say this should be the exactly the revenue function that we gonna use for that example. So I'm going to use 200 minus x times x for the revenues. Or actually, I'm going to have revenue x from the previous example. It's going to be, I forgot the function already, sorry. Let me go back. Negative x squared times negative x squared plus 200x. Uh-oh. Okay. Negative x squared plus 200x. That's going to be the function of the revenues from previous I forgot the word from the example above. Okay, so now come back with the profit function. I will have profit equal to revenue function minus with a cost function, right? So let's use revenue function in red color. Oh, red color here. So that's going to be negative x squared plus 200 x, right? And I'm going to use green color for the cost function. 6500 plus 20 x. And then simplify time. So I'm going to have x squared negative x squared plus 200x minus 6500 minus 20x. So you will have negative x squared plus 180x minus 6500 that's gonna be the profit function for our example. So let me say the graph shows the revenue and cost function. Okay, so the blue line here is for the revenue function, the graph of the revenue function, and I say brown line here is for the cost function, C of x. And what does P 100 mean? Mark it on the graph. Okay, so for the P100, you will have substitute into, you may substitute into here, right? Or you can use substitute into the revenue function, revenue at 100, and you subtract for the cost at 100, right? And then you should have say revenue at 100 where's the revenue function? Is here, and that's going to be 10,000. And then minus for the cost is 100. So let's come back with 100 here. Go back up to the graph of the C-Rex here, and that should be about 700 and 7,500. Oh, actually, no. My eye is terrible. Actually, that should be 8,500. Okay. Or you can substitute into the CX here, right? You're gonna have 6,500 and it plus with 20 times 100. So that's gonna be 2,000. So 6,500 plus 2,000 gonna be 8,500. So 10,000 minus for 8,500 will be equal to 1,500. And you can circle this at the answer. So so I want to mark it on the graph. So 1,500 will be here. Okay, so use this one. So that's gonna be the profit. Okay, so gonna be 100, 1,500. So so what does if it's a what does a profit 100 mean? It actually mean it is the difference between the revenues and cost. So you actually try to find the distance between the revenue and cost in here, and you should know that that is exactly the distance from 0 to 1,500 is. So then we can know that the profit right now is 1,500. Okay. Let's move down. So now we'll talk about break-even points. We learned last time about break-even points, which is at the time that revenue and the cost are equal to each other. So so if you wanna come back with the graph here, the break-even point is to this point that you're gonna have the cost and the revenues, they are equal, and you don't make any profit. These 2 points. Okay, so let me get down. Oh. All right. So so this is the definition of the break-even points, and in order to find it, you need to set C of x equal to x and then solve for x. Or okay, so then okay, so let's try to find it, right? So from according to the the function of cx below, above, I have c of x. Let me get up a little bit. Uh-oh. C of x equal to 6,000. Find x plus 20x. And then for the revenues, it's going to be equal to negative x squared plus with 200x. Okay. So now I'm going to set to this equal each other like this, right? Now I substitute it. Have 6,500 plus 220x equal to negative x squared plus 200x. So I'm gonna add both sides by negative x squared. I'm gonna add both sides by x squared, right? And I'm gonna minus both sides by 200x. Then I'm gonna have x squared for the left hand side plus minus 180x, and then plus with 6,500 and equal to 0. Okay, so so then you will have a quadratic function, right? And you can use the quadratic formula, or you can use factor. I'm not sure if you can factor this, but I think yes, you can. You can factor this as x. That use a AC method. So A times C equals 6,500. B equal to negative 180. So here's B, here's A times C, right? And then two number, you're gonna find two number multiply equal to 6,500 and addition equal to negative 180. So that should be equal to say 50, negative 50 and negative 130. And you can try that try to use that, multiply that to see if it equal to 6,500, but I'm pretty sure it equal to. Okay, now since you can find it already, you can have factor form as x minus 50. Remember that we are having in this case a equal to 1. So you can right away apply factor. You can right away factor is at the format x, adding these two number, but this is a negative, so and I minus, so 130 and equal 0, right? So then you can easily have x equal to 50 and x equal to 130 by using factoring AC method. But you can also use the quadratic formula by applying AB in here. I mean negative B plus and minus for square root of B square minus 4 times AC and divided by 2A. So then you also will have same answer as x equal to 50 and x equal to 130, but you have to do carefully to find it. So then these two break-even point is 50 and 130. So let's move down a little bit. I have the cost and revenue function equal at x equal to 50 and x equal to 130. So we want to find if the revenues and the cost, they are equal each other. So I have to rewrite the revenues for revenues function equal to 200x minus for the x squared, and for the cost it is 500 plus 20x. So use a calculator. You will have 200 times 50 and minus 450. You're gonna have 7,500. One more time. $7,500. And use another one. You're gonna have 6,500 plus 20 times 50. You're gonna have cost now also gonna be equal to 7,500. And for the another break-even point, I will let you guys do it, but I'm pretty sure it had to be the same value. So move down. Okay, finding profit from the graph of the revenue and the cost. As I said before, the profit will be the difference between the distance between the revenue and the cost. So if you but remember that you have to take the revenue subtract for the cost. So in here, what the arrows on the graph below show. So if you say in here, what is that? 50, 60, 70, 80. You are in the 80, you will have the profits is a positive profit. So this is like, I don't know, but I'm gonna say a positive profit, right? And if you go up to 150, say x equal to 150, but then you don't, I mean, you have a negative profit. Negative profit because of why? Because in this case, you have the cost. The cost is greater than the revenues. So that means when you take the subtraction between the revenue with the cost, you're going to have a negative. Okay, or I'm going to say profit is less than 0, and here is profit greater than 0. So actually, in order to get the profit greater than zero, you need to make sure your profit is in the area between x equal to 50 and x equal to 130. So then you're gonna have profit gonna be um, greater than 0. Okay.